All right, good morning, guys. This is our Exponent Rules graphic organizer. A lot of you guys have already done Exponent Rules. This may be something we have already done in class, but again, as a Math 1 group, we are told to keep the same material amongst all Math 1 classes. So we're going at the same pace. Everybody else in any other Math 1 class is doing the same thing we are. So some of this we might have already done, but that is perfectly fine. So when it comes to adding and subtracting monomials, you will combine like terms. They have to have the same variables and the same exponents, and you do not change those variables or exponents. So if you notice for number 1, we have x squared y, and we also have x squared y here. So our answer will have x squared y in the final answer. Now we just have to use the coefficients. So it's 9 minus 10, and that will give me a negative 1. You can put the 1 here, but I will not do that. It's not incorrect if you do that, but you can just leave the negative out there. So then you have subtract 6w from 8w. Again, subtract from our turnaround word, so it really looks like this, 6w, or 8w minus 6w. Now, it's the same thing as above, it's just this is a lot easier, and this is simple. You've been doing this for a while. You're telling yourself, okay, that's easy, 2w. Well, what you didn't realize is the variables are the same and the exponents are the same. So that's why we can do this. So that will be 2w, and we don't change those variables, nor do we change their exponents. Now, on the product rule, for product rule, you have x to the a power times x to the b power, where x is just any random variable, and we will add those exponents. Okay? Anytime you're multiplying, so between these two monomials we're multiplying, but that tells us to add those exponents. So that will be h to the 8th power. Now those are exponents. When you have coefficients, you just multiply them like usual. Negative 2 times 7 will give us a negative 14. And then for our exponents, we will add those. So we have a squared and a to the 3rd. That'll give me a to the 5th. And b to the 1st and b to the 1st, that will give me b to the 2nd. That's one mistake that I see a lot of people make. Now, power rule. When you are raising something to a power, see the difference between product and power. For product, you're multiplying. For power, you are raising it to a power. Here is where we will multiply. So x is our variable, and we will multiply a times b. So for number 1, instead of it being x to the 5th, we are multiplying now. That will be x to the 6th. The same thing here for number 2. Be very careful with this. That 2 is a power. So we're raising negative 2 to the 2nd power. That'll be positive 4. And then we're doing m to the 5th to the 2nd power, which will be m to the 10th. We take that and then multiply it, product rule, by m to the 3rd. So that will give us m to the 13th. Whenever we are multiplying, we add those exponents. So that's a good problem to kind of keep everything in check and know what you're talking about. So for multiplying, we added these two. For dividing, we're going to subtract those two. So that's going to be x to the a minus b power. And when you divide the coefficients just like normal. So 27 and 42 can both be divided by 3. So if I divide them both by 3, 27 will be 9, 42 would be 14. And then for these exponents, that's 5, and this x is a 1, so that would be x to the 4th. Now, that x to the 4th will stay up top because the 5 is greater than the 1. If it was the other way around, if say there was a 6 on the bottom, then we would throw that x in the denominator. However, you can also write it like this. Anytime it's in the numerator, you can write it to the outside, but I'd like for you to keep it in the numerator just to keep things straight. For number 2, what rule do we have here? That is a power. So we are going to do power rule and multiply. That'll be y to the 4th over y to the 4th. And that, since they're the same, will just give you 1, right? Y to the 4th over y to the 4th. But here's why. So you will have y to the 4 minus 4, which will be y to the 0 power. So this is why everything over itself is 1, because it's being raised to the 0 power, and anything to the 0 power is 1. Now we have negative exponents. Anytime you see a negative exponent, you need to make that a reciprocal. In other words, you need to put that on the bottom and make it a positive exponent. Now, you only do this with the exponents themselves, not any coefficients. So you see this -5. That's just a -5. We're not going to put it underneath and make it a +5. That's still -5. But our variable and the exponent will go on the bottom, and that exponent will become positive. For number 2, we have 4/8, which will be 1/2. And this is what I was talking about before, where now the bigger variable is in the bottom. So if we add 2 minus 5, that will be k to the -3rd power. 2 minus 5 is -3. But instead of doing it like that, it is perfectly fine to put k to the 3rd and just put it in the bottom, right there. Those are the exact same thing. However, I do not want you to leave it as a k to the -3rd up top. You can't leave a negative exponent in your final answer. So this would be incorrect if you put it as a final answer. But it would be okay if it was just a step in your problem and then you move that k to the 3rd down to the bottom. Now, lastly, I already talked about this 0 exponent rule. Anything to the 0 power is 1. So that's 7 times x to the 0 power, which is 1, would just give us 7. But be very careful with that in different cases like this, like what we've already have. So this is product rule right here, or power rule. So we will multiply our exponents, w to the 8th divided by w to the 8th. That will equal w to the 0 power, which we know is 1. So there's a little exponent review. We're going to do a practice on each one of these. Exponents are something that even my Math 2 and my Math 3 students still struggle with. So if there's anything that we can cover in this time, and it may seem really easy for some of you, but this is something that I need all of you to know immediately. I should be able to give you any one of these, and you should be able to spit out exactly what to do. So I definitely want you to build up some confidence with exponent rules, and here's a